This is a recast of the 5,400-word piece Symbolic AI versus Subsymbolic AI from Symbolic AI. This article compares Symbolic AI, which uses abstract representations and rules, with Subsymbolic AI, which simulates the learning processes of biological organisms using neural networks. It discusses the strengths and weaknesses of each approach and their practical applications in various fields, noting that a combination of both approaches can lead to more effective AI systems. The article also highlights ongoing debates in the field of AI and the importance of considering the deeper implications of creating independent AI entities. Let's listen in.
So the article talks about two approaches to artificial intelligence, symbolic AI and subsymbolic AI.
That's right. Symbolic AI uses symbols or abstract representations of knowledge, rules, and concepts to solve problems and make decisions. Subsymbolic AI, on the other hand, simulates the learning and decision-making processes of biological organisms using neural network architectures.
Symbolic AI is often used in expert systems and natural language processing, while subsymbolic AI has seen breakthroughs in areas like computer vision and deep learning.
That's correct. Symbolic AI relies on logical deduction and inference based on a set of explicitly defined rules to solve problems. Subsymbolic AI, on the other hand, uses numerical methods and statistical models to analyze data without explicit rules or algorithms.
This comparison is significant in highlighting the strengths and weaknesses of each approach and identifying areas where they can complement each other.
Absolutely. Comparing symbolic and subsymbolic AI helps in devising a more comprehensive framework for developing artificial intelligence programs.
And by using both approaches together, we can create more sophisticated programs that are better suited to solving specific problems.
Subsymbolic AI is particularly well suited for solving non-deterministic, complex, and dynamic problems that require non-linear or continuous solutions.
Right. This is because subsymbolic AI can learn and adapt to new information more easily than symbolic AI.
However, subsymbolic AI has limitations. It lacks explanation and interpretability, which can make it difficult to understand how it arrives at a solution.
And the complex algorithms used in subsymbolic AI systems can make them difficult to modify or adapt. Therefore, subsymbolic AI requires a thorough understanding of neural networks and deep learning techniques to be effective.
Overall, comparing symbolic and subsymbolic AI is essential in understanding the development of artificial intelligence and creating more sophisticated programs that can solve specific problems.
That's right. Symbolic AI, as the article explains, relies heavily on predetermined rules to make inferences and decisions. It is useful in expert systems and problem-solving applications, but has limitations when it comes to dealing with complexity and uncertainty.
On the other hand, subsymbolic AI uses neural networks to learn patterns and relationships from vast amounts of data, making it more flexible and adaptive. It has proven effective in tasks such as image and speech recognition, natural language processing, and medical diagnosis.
Neural networks are composed of artificial neurons that function as signal processing units, and subsymbolic AI is built on the concept of creating computational models inspired by the human brain.
While the interpretability of subsymbolic AI may be an issue, its ability to learn and adapt without explicit programming is a significant advantage over symbolic AI.
However, as we mentioned earlier, the complex algorithms used in subsymbolic AI can make it difficult to modify or adapt. Therefore, a thorough understanding of neural networks and deep learning techniques is crucial for its effectiveness.
It's essential to consider the strengths and weaknesses of each approach when developing AI programs for specific applications.
Absolutely. Symbolic AI has proven successful in addressing specific problems, but has limitations in handling large amounts of data, while subsymbolic AI requires significant computing power and processing time, but can learn on its own and adapt to new patterns.
So it's a matter of finding which approach is suitable for the specific problem at hand.
That's right. And as technology continues to advance, it's exciting to see how both symbolic and subsymbolic AI will continue to evolve and innovate.
Well said.
Yes, subsymbolic AI is based on the concept of neurons, which are interconnected and work together to complete a task. These networks can learn from examples and continuously adjust their connections for improved performance, a process called training.
That's right. Subsymbolic AI systems can be used for tasks such as image recognition, speech recognition, and natural language processing. They work by processing data through layers of nodes, simulating the way the human brain processes information.
The article mentions that this subsymbolic approach has led to breakthroughs in areas such as machine learning and computer vision.
Exactly. Deep learning, a subfield of neural networks, has enabled algorithms to recognize images and texts with a high degree of accuracy. Subsymbolic AI is essential for creating more human-like and adaptable intelligent systems.
And while subsymbolic AI is great at recognizing patterns and processing large amounts of information, symbolic AI is better suited for well-defined problems that have simple solutions.
Symbolic AI is based on knowledge representation schemes and operates on discrete and structured approaches that enable humans to comprehend and analyze the logic behind a machine's decision-making process.
And while symbolic AI had its limitations in handling uncertainty and ambiguity, it is still a popular field of research today.
That's right. Its applications can be seen in various fields like natural language processing, robotics, and computer vision.
And when it comes to subsymbolic AI, some examples include artificial neural networks, ANNs, deep learning algorithms, and decision trees.
ANNs are modeled after the structure and function of the human brain and are used in image and voice recognition, natural language processing, and autonomous vehicles.
Deep learning algorithms, which are a subset of ANNs, use multiple layers to analyze data and make predictions. They're used in applications such as speech recognition, natural language processing, and image recognition.
And lastly, decision trees are used in medical diagnosis, credit scoring, and fraud detection, among others.
So both symbolic and subsymbolic AI have their own strengths and weaknesses, which can be utilized in different applications.
Yes, symbolic AI is adept at reasoning and representing knowledge explicitly, but criticized for its brittleness and inability to learn from data.
Whereas subsymbolic AI provides a more implicit way of representing knowledge and is useful for tasks that require pattern recognition and learning from data, but may not be suitable for more complex reasoning tasks.
That's where hybrid approaches that combine both symbolic and subsymbolic AI techniques come in. They have been proposed to leverage the strengths of both and overcome their limitations.
Ultimately, the choice between these approaches will depend on the specific problem and domain being tackled.
And as AI continues to evolve and advance, it is likely that new techniques and approaches will emerge, further expanding the capabilities and potential applications of artificial intelligence.
One of the main points of the article is that there are two main approaches to artificial intelligence: symbolic AI and subsymbolic AI.
Symbolic AI, also known as rule-based AI, relies on formal logic and symbols to reason about problems and is best suited for expert systems that require human input and domain-specific knowledge.
On the other hand, subsymbolic AI uses techniques like neural networks, fuzzy logic, and evolutionary computation to learn from data and make decisions based on patterns. It's ideal for applications that require continuous learning, such as natural language processing, speech recognition, and image recognition tasks.
Both approaches have their strengths and weaknesses. Symbolic AI is good at logical reasoning and deduction but may struggle with complex or uncertain data. Subsymbolic AI is great at learning from data but lacks transparency and interpretability.
The article also highlights the practical applications and limitations of both approaches. Symbolic AI is suitable for tasks that are solely based on rule-based reasoning like natural language processing, expert systems, and robotics, while subsymbolic AI is ideal for tasks that require low-level processing like image processing, speech recognition, and pattern recognition.
Despite their distinct features, it's important to recognize that the practical applications of both approaches are not mutually exclusive, and combining them can lead to better performance in some cases.
It's clear that both symbolic AI and subsymbolic AI offer complementary avenues for developing intelligent systems.
Absolutely. And as AI continues to evolve and advance, it's likely that new techniques and approaches will emerge, further expanding the capabilities and potential applications of artificial intelligence.
It's exciting to think about the possibilities. One of the ongoing debates in the field of AI is between symbolic AI and subsymbolic AI. Symbolic AI relies on human-like cognitive processes such as reasoning and logic, while subsymbolic AI mimics the ways in which the brain processes information.
That's right. Symbolic AI proponents argue that it is the only way to achieve true intelligence and understanding, as it relies on logical representation and rule-based systems. They view subsymbolic AI as limited in its ability to produce truly intelligent behavior because it lacks the ability to reason abstractly.
On the other hand, subsymbolic AI enthusiasts argue that it offers a more flexible and powerful means of achieving intelligence. By using neural networks and machine learning algorithms, subsymbolic AI is better able to handle the complexity and variability of real-world situations. Moreover, it is less dependent on hand coding and is able to learn from experience, thereby achieving greater accuracy and adaptability over time.
But there are also criticisms for both approaches. Critics of symbolic AI argue that it is limited by its inability to handle ambiguity and lack of robustness in the face of incomplete or noisy data. And critics of subsymbolic AI argue that it lacks transparency in how it makes decisions, preventing humans from understanding how the system arrives at its conclusions.
It's important to consider both approaches in the development of AI. Symbolic AI is advantageous in situations that require logical reasoning and problem solving, whereas subsymbolic AI excels in areas where pattern recognition and learning from experience are important.
That's right. And combining both approaches can lead to more comprehensive and intelligent AI systems that can overcome the challenges and limitations of individual approaches.
Looking ahead, as AI continues to advance, we need to consider the deeper implications of creating independent AI entities. We must ensure that such entities do not perceive us as a threat, and that we do not perceive them in the same way.
Overall, it's important to understand the strengths and limitations of both symbolic and subsymbolic AI and apply them in a complementary manner to create more effective AI systems that benefit society as a whole.